motors.
Introduction to DC motor. Our topic will focus on what is DC motor, the different parts of DC motor, how DC motor works, types and application of DC motor. What is DC motor? It says here, a DC motor is an electric motor that runs on direct current power. In an electric motor, the operation is dependent upon simple electromagnetism. It is a current carrying conductor generates a magnetic field. When this is then placed in an external magnetic field, it will encounter a force proportional to the current in the conductor and to the strength of an external magnetic field. It is a device that converts electrical energy to mechanical energy. It works on the fact that a current carrying conductor placed in a magnetic field experiences a force that causes it to rotate with respect to its original position. Practical DC motor consists of field windings to provide the magnetic flux and armature which acts as a conductor. Let's proceed to the different parts of DC motors. In DC motors, there are different popular designs of motors that are available like brushless, permanent magnet, series, compound wound, shunt, otherwise stabilized shunt. So in general, the parts of the DC motor are the same in these popular designs but the whole operation of this is the same. The main parts of the DC motor include the following. Number 1. Stator. The stator comes from the word stationary, meaning it is the electrical stationary parts of a DC motor. Stator does not move and only produces a magnetic field around the rotor to make the rotor rotate when the voltage is applied to it. Stator is built from yoke or frame, field windings, and poles. Number 2. Rotor. The rotor comes from the word rotate, meaning it is the electrical rotating part of a DC motor. The rotor is the moving part of a DC motor. It dynamically moves when the voltage is applied to the armature winding. This will produce mechanical movement for a DC motor. So this one is the important part of a DC motor. Rotor is built from shaft, armature core, brush, commutator, and armature windings. Number 3. Shaft. A motor shaft is a cylindrical part that protrudes or extends beyond from the motor and housing. The shaft function is to transfer energy from the motor to the intended use. Operating in relation to speed and torque are precision pins and shafts. Number 4. Commutator. The commutator has the form of a split ring. The ring is made from copper and split into 2 or more depending on the number of armature windings. The split segment is connected to the armature winding. So the main purpose of the commutator is to deliver the electric current to the armature windings. Number 5. Field winding. The field windings are made from copper wire and circle around the poles. Field winding is used to energize the static magnetic field in the stator. Number 6. Yoke or frame. Yoke is an iron frame as a protective cover for both rotor and stator. So this part protects everything inside it, supports the armature and the house of the magnetic poles, field windings, and the pole to provide magnetic fields for the rotor. Number 7. Armature windings. The armature winding of the DC motor is attached to the rotor or the rotating part of the machine, and as a result, is subjected to an altering magnetic field in the path of its rotation, which directly results in magnetic losses. Number 8. Brushes of DC motor. The brushes of the DC motor are made with carbon or graphite structures, making sliding contact over the rotating commutator. The brushes are used to relay the current from the external circuit to the rotating commutator form where it flows into the armature winding. Number 9. Poles. Poles in the stator are used to energize a specific sequence of magnetic poles to make sure the rotor is rotating. It is divided into pole core and pole shoes. These pole shoe and pole core parts are attached to each other using hydraulic pressure. The structure is the yoke holding the pole core, which carries the pole shoes carrying field windings. This pole unit generates flux spread out into the air gap between rotor and the stator. The working principle of DC motor will be reported by Norben Escalora.
DC motor working. The principles of working of a DC motor is that whenever a current carrying conductor is placed in a magnetic field, it experiences a mechanical force. The direction of this force is given by Fleming's left-hand rule, and its magnitude is given by F equals BIL, where B equals magnetic flux density, I equals current, and L equals length of the conductor within the magnetic field. Fleming's left-hand rule. If we stretch the first finger, second finger, and the thumb of our left hand to be perpendicular to each other, and direction of magnetic field is represented by the first finger, direction of the current is represented by second finger, and the thumb represents the direction of the force experienced by the current carrying conductor. Fleming's left-hand rule is used to find the direction of the force acting on the current carrying conductor placed in a magnetic field.
The different types of DC motor will be reported by Marlo Franz Galos.
Types of DC motor. There are three types of DC motors. First is separately excited, second is self-excited, and third being permanent magnet. Under self-excited, there is shunt excited and compound excited, and under compound excited is cumulative compound and differential compound, and under them is long shunt and short shunt. Separately excited DC motor. In a separately excited DC motor, the motor has separate electrical supplies to the armature winding and field winding, which are electrically separate from each other. The operations of the armature current and field current do not interfere with each other's actions, but the input power is their total sum. Permanent magnet DC motor. A permanent magnet DC motor has an armature winding but does not have a field winding. The permanent magnet is mounted on the inner surface of the stator core to produce the magnetic field. It has a regular armature consisting of a commutator and brushes. Permanent magnet DC motors are smaller and less expensive. They use rare earth magnets such as samarium, cobalt, or neodymium iron boron. Self-excited DC motor. In self-excited DC motors, the field and armature windings are connected and have a single supply source. The connections are parallel or series, with parallel made as shunt wound, while the series version is series wound. Shunt-excited DC motor. In a shunt-wound DC motor, the field and armature windings are connected parallel to each other. This exposes the field winding to terminal voltage. Though the supply is the same, the current for the field and armature winding is different. The speed of a shunt DC motor is constant and does not deviate with varying mechanical loads. Series DC motor. The field and armature winding on a series DC motor are connected to the power supply in a series. The same current flows in the field and armature windings. A series wound motor can work with AC and DC voltage supply, which makes it a universal motor. Series motors always rotate in the same direction regardless of the voltage source. Their speed varies with the mechanical load. Compound DC motor. A compound DC motor uses the features of the series and shunt field windings. The winding for the armature is connected in a series while the winding for the field is a shunt or parallel connection. Compound DC motors are further divided into cumulative and differential. With cumulative DC motors, the flux of the shunt field helps the flux in the series field. They both move in the same direction while the flux of a differential compound DC motor for the series and shunt fields moves in the opposite direction. Cumulative compound. Cumulative compound motor. The magnetic fields of the series and shunt windings in a cumulative compound motor add together, resulting in a stronger overall magnetic field. This provides an increase in torque, making it suitable for heavy load applications. Differential compound. In differential compound motors, the magnetic fields of the series and shunt windings oppose each other. The speed of this type of motor increases with the load, making it less common in practical applications. Short shunt DC motor. The type of compound DC motor in which the parallel combination of shunt field winding and the armature winding is connected in series, with the series field winding known as short shunt compound DC motor. Long shunt DC motor. A compound wound DC motor in which the series combination of armature winding and the series field winding is connected in parallel with the shunt field winding is known as a long shunt compound DC motor. Brushless DC motor or BLDC. Brushless DC motors, known as BLDC motors, are a permanent magnet synchronous electric motor driven by direct current and an electronically controlled commutation system. The process of producing rotational torque by changing phase currents. They are also referred to as trapezoidal permanent magnet motors. Brushed DC motor. Brushed DC motors are one of the simplest types of DC motor. It uses brushes to deliver current to the motor windings through mechanical commutation. The number of coils wound around the motor and the density of the coils determine the properties of the motor. The armature or rotor is an electromagnet. The field magnet is a permanent magnet. This motor does not require any controller to operate or vary the speed.
The DC motors application will be reported by Norben Escalora.
DC motors applications. DC motors are used in any number of applications since they have a high starting torque compared to induction motors. Brush DC motors are easy to miniaturize and they provide a good rotational control as well as high efficiency. Brushless DC motors have a long life due to their lack of wear from brushes, are easy to maintain, and are noiseless. The list below provides description of the few of the millions of use for DC motors. DC motors used in electric vehicles, cranes, conveyor system, ceiling fans, pump drives, elevators. At home, small DC motors are used in tools, toys, and various household appliances.